Okay, this is a major type of problem that you're going to have to do in U4A4. So this video here is probably more important than the first one. What you're going to do here is you're going to be mixing things. So you're going to have 500 mils of two solutions. You've got 4 times 10 to the negative 5 molar AgNO3 and 8 times 10 to the negative 4 molar NaCl. And what is the mass of the precipitate? So the first thing you have to do is you have to put the two molecules down. So the molecules are made up, because they're salts, they're made up of a cation or positively charged first part, the metal, Ag, and a negative section, NO3 or nitrate in this case. Sodium chloride is going to be the same thing. So it's a salt, it's made up of a metal and a non-metal. And what happens is the two metals trade spots in this double displacement reaction. So what we end up making is AgCl and NaNO3. One thing I would highly suggest you download is a solubility table. And what that's going to tell you is what forms a precipitate and what does not. NaNO3 is soluble, so it will not form a precipitate. It will be aqueous. Aqueous means dissolved in water. AgCl, on the other hand, is not fully soluble or insoluble, and it can form a precipitate. Now what we have to do is we have to do a K-test to see if a precipitate will form. First thing you've got to do is set up your double displacement reaction. They'll all be double displacement reactions. Switch the two partners out front and then see which one of these is insoluble, if any. So we've got 4 times 10 to the negative 5 molar, which means we have this many moles in 1 liter, but we've only got 0.5 liters. So that's 2 times 10 to the negative 5 molar. And same here. We are only using half of a liter, so we've got a half our amount for our molarity. What you want to do is you want to set up a K-test, so it's the same as KSP. It's going to be x squared here because it is a 1-to-1 ratio of Ag to Cl. So when we multiply these together, we get 8 times 10 to the negative 9. So what we're trying to do right now is see if we're going to make a precipitate or not. To make a precipitate, this calculation that we did here has to be higher than the KSP value. So this is the maximum amount of AgCl that can dissolve in 1 liter of water. And this is what we have, 8 times 10 to the negative 9. Since this number is greater than the one found in the KSP table, we are going to get a precipitate. So now we have to see how much of a precipitate we have. So what we have to do is we have to set up an ICE chart or an IRE chart. So what you do is you write down your amounts of Ag and Cl that you're going to be putting into solution. We are going to start with 0 of the AgCl. Now, you can only take away from this side because you have stuff there. You don't have anything there, so you can't take away. You can only take away a maximum of your smallest amount, which is 2 times 10 to the negative 5. So what happens is you can only react 2 times 10 to the negative 5 here, so you can only react 2 times 10 to the negative 5 here. If we subtract that, we end up with 0 here. And what we end up here is 4 times 10 to the negative 4. I better make sure that I've got this right. Minus the 2 times 10 to the negative 5. I don't know if this is right, but I've got 3.8 times 10 to the negative 4. I want to try that one more time. That seems a little off to me. 4 times 10 to the negative 4, subtract 2 times 10 to the negative 5 equals. Okay, there we go. And over here, we are going to subtract from the reactant side. We're going to add over here. So we're going to get 2 times 10 to the negative 5. That's how much AgCl we're going to form. It's asking us for our mass of the AgCl. Mass is equal to moles times molar mass. So all you do is you take these moles here, this is what the chart's giving you, moles per liter or moles, and you're going to multiply that by the molar mass of AgCl. Just go to the periodic table to look that up.